Welcome to the debate. We are well past the era of simplistic large language model autocomplete. We are now firmly grappling with the agentic coding era, where AI is capable of autonomously executing multiple steps, accessing existing code bases, modifying files, running tests, and managing state, all without, immediate human intervention at every single keystroke.
Right.
So for any executive, founder, or operational leader, the core question isn't what can this technology do, but where does it deliver measurable, scalable operational value against our real-world constraints of quality and risk? And today we confront that precise tension. Does the required extensive, expert human control over these AI agents fundamentally limit the scalable business value they can deliver, or is this control merely a necessary governance layer that ensures software quality? I'm going to argue for the latter. That controlled implementation is the necessary best practice that unlocks sustainable productivity gains.
Well, I come at it from a different way. While that initial acceleration is compelling, the pervasive need for constant human supervision and the agent's demonstrable inability to execute high-leverage business logic functions, that proves their operational role is currently confined to low-return tasks. This mandated high level of operational overhead, this constant validation, it creates an inefficient bottleneck that I think severely constrains any notion of scalable, capital-efficient value we might hope for. We have to distinguish between augmentation and true delegation.
My position is grounded in the operational reality that quality and long-term maintainability are non-negotiable enterprise requirements. We simply must prioritize reliability over rushed autonomy. The operational value of these agents is significant right now precisely because they provide a necessary productivity boost, a sentiment valued by, I think it was, over 36 experts in our source material, by effectively accelerating routine low-level friction points. We see near-universal agreement among experienced developers that agents are highly suitable for handling tedious or repetitive work and, generating the necessary scaffolding or boilerplate code for new features. The data shows this utility is almost without question. More crucially, the human expert's supervisory role ensures the final output meets enterprise quality standards. When asked what was most important when accepting agent output, respondents overwhelmingly cited correctness and readability. So this control isn't an operational drag. It's the process of translating established multi-decade software engineering principles, like rigorous review and testing, into a modern agentic workflow. This secures long-term reliability and reduces future unmanageable technical debt. That is an undeniable, measurable strategic business value.
That's a compelling argument for quality control, I'll give you that. But I just don't buy that the marginal gains outweigh the supervision cost, particularly when you factor in the massive opportunity cost of redirecting senior engineering time. The core operational flaw, for me, is that agents fail precisely where true differential business value and competitive advantage are created. Look at the constraints the experts reported. Agents perform poorly on complex tasks, tasks requiring intricate or complex logic, and critically, tasks that require specific business or domain knowledge. These are the functions that underpin your core product, your revenue growth, and they remain exclusively human territory.
Sure.
And furthermore, the supposed automation quickly becomes illusory when we examine the actual required oversight. Developers report modifying agent-generated code about half the time. They rate the necessity of modification at, 3.0 out of 5. They also instruct agents to work on an average of only 2 steps at a time, requiring constant vigilance and human validation between these microtasks. This is not scalable delegation. This is constant, expensive oversight on low-leverage tasks. If we are asking senior talent to spend half their time validating output and constantly course-correcting microsteps, the operational cost of managing the agent begins to negate the efficiency gain of its mechanical output. We really need to push back on this definition of productivity boost.
If agents are only suitable for marginal functions like simple bug fixes or writing basic unit tests, the marginal time saved does not compensate for the organizational risk and overhead required to ensure the agent doesn't corrupt existing systems or introduce unforeseen vulnerabilities. The source material clearly highlights agent weakness in integrating with existing code or handling legacy environments, reporting these tasks as overwhelmingly unsuitable for agent work. In an established enterprise environment, that failure point is a severe risk amplifier. It immediately increases integration risk and forces costly manual cleanup, potentially negating any minor acceleration gained from boilerplate generation. We are trading low-value time savings for potentially high-value system integrity risk.
That's a critical point regarding risk, and I agree that complexity presents real limitations. But I would frame the operational benefit differently. The ability to offload what one respondent succinctly called the mundane. That removes a significant amount of administrative and repetitive friction. We're talking about automating general refactoring, maintaining internal documentation, and generating routine scaffolding. By accelerating these processes, we are achieving a strategic reallocation of expert capacity. Think of your most expensive, high-value engineers. They are now free to focus their finite time on critical architectural decisions, defining complex feature requirements, and engaging in high-level problem-solving, where human judgment offers the highest possible return. The goal here isn't to replace the human, but to maximize the value input of that expert talent by shifting peripheral but necessary work to a capital resource.
This shift away from low-leverage execution is a clear strategic operational gain that improves project velocity and code quality simultaneously.
But I'm not convinced that the operational cost has actually been reduced. I think it's simply been transferred into a different, equally expensive cognitive domain. If we look closely at the successful agent interactions, the ones that actually led to production-ready code, they often required large, highly detailed plans referencing specific files, UI terms, and complex technical concepts. The expertise needed to articulate the exact implementation plan to the agent suggests the expert is simply translating their fully formed solution into an incredibly granular prompt rather than delegating true problem-solving. This detailed translation effort, this necessary pre-computation and planning, that is the new operational cost of using the agent. Instead of writing the code, the expert is writing the extremely complex specifications for the code, which reduces the net productivity gain because the cognitive load of solution design is undiminished.
You're focusing exclusively on the friction in the prompt engineering phase. And while that friction is real, the expertise required to control agents is primarily an essential, non-negotiable governance layer fundamental to preventing long-term operational failure. If we let agents run unsupervised on complex tasks, we risk poor architectural choices that can come to bite back, as one expert put it. This is why practitioners explicitly avoid agents for high-stakes or privacy-sensitive tasks. The control mechanism is what converts raw machine output into a production-ready asset. Experienced developers ensure this using established best practices, systematic testing, meticulous version control, and rigorous code review. For example, one developer, P6, systematically ensured agents generated test cases for every single agentic change, improving overall test coverage across the system. This isn't a constraint on the tool's inherent value. It's responsible operation, applying the lessons of decades of engineering wisdom to mitigate unacceptable risk in a modern development environment.
That's a compelling argument for system integrity, and I agree that security and architecture demand governance. Where we diverge is whether that specific governance needs to be manual, senior human labor. If the most effective strategy for successful use is fundamentally defined as applying the established lessons of software engineering to a narrative prompt and relying entirely on the developer's ability to verify every line of code, structure, and syntax, then the AI is functionally merely a sophisticated junior assistant. It is fundamentally unsuitable for replacing the cognitive functions of human expertise or high-stakes architectural decision-making. For any executive planning long-term capital allocation and, budgeting for headcount, the conclusion is troubling. Scaling the use of agents requires scaling human judgment, verification, and oversight at a proportional rate. This fundamentally defeats the premise of capital efficiency, often attributed to AI automation. You have outsourced the typing, but you have not outsourced the ownership or the accountability.
I see why you think that. And the challenge to the premise of capital efficiency is valid if one views this purely as a resource replacement strategy. But let me give you a different perspective on the trade-off. The practitioners themselves, the engineers on the ground, they tacitly acknowledge that the alternative to this rigorous controlled use is a high-risk, low-quality approach that we might call vibe coding. For enterprises focused on measurable outcomes, reliability, and market trust, accepting the control mechanism is the explicit trade-off that unlocks the productivity benefit while entirely mitigating the unacceptable risk of unmaintainable or insecure code. You cannot measure operational value if the code is unreliable or unmaintainable. The expert human review is not a constraint. It is the necessary bridge that transitions a technological proof of concept into a reliable, production-ready asset. We have to think about net operational gain, factoring in long-term maintenance costs.
Okay, let's pivot to high-leverage strategic work then, design and architecture. If we look at the potential for these agents to assist leadership, the data clearly shows that high-level plans like project or system architecture design are fundamentally unsuitable for agents. We see a significant majority of responses indicating unsuitability, often due to the complete lack of necessary domain knowledge and the inability to synthesize complex, novel business requirements. This value point establishes a clear, measurable ceiling on the agent's ability to contribute to the highest value organizational decisions. They accelerate low-level mechanical execution, but they cannot shape the strategic direction of the business or ensure the integrity of the long-term system architecture. This failure to contribute at the strategic layer limits the overall return on investment.
Well, I fully agree that full delegation of strategic design is inappropriate. The human must always maintain ownership of the vision. But the data also shows agents are highly valued as collaborative tools that significantly improve human decision quality and speed during that crucial planning phase. This is an augmentation play, not a replacement one. Developers actively use agents for complex brainstorming, for exploring alternatives rapidly, and for collaboratively talking out problems. One developer even referred to the agent as a sophisticated rubber ducky, helping them avoid cognitive blind spots and expediting the overall human design process. The operational pivot here is recognizing the distinction between delegation, which fails for complex high-stakes tasks, and collaboration, which demonstrably succeeds for planning and design by augmenting the quality and speed of human judgment. By accelerating and improving the quality of the crucial early planning phase of the software development lifecycle, we achieve a measurable, strategic impact that goes beyond simple bug fixes.
But the quality of that strategic collaboration is inherently tied to the agent's ability to rapidly explore alternatives, which still brings us back to the domain knowledge constraint. If the agent cannot handle tasks requiring specific business or domain context, its utility as a strategic brainstorming partner is limited only to generic textbook architectural patterns. It can't challenge the expert based on the unique competitive landscape or the firm's proprietary data structures. Therefore, while it might provide a quick sounding board, it doesn't fundamentally change the expert's requirement to perform the deep, high-stakes analysis alone. The agent remains a generalized aid, not a differential decision driver.
The material confirms that AI agents provide meaningful operational acceleration when used responsibly as collaborative tools under the strict governance of expert software development principles. For executives, the critical takeaway is this: value capture is achieved not by chasing maximum autonomy, but by strategically focusing agents on the specific areas where they demonstrably excel: simple, repetitive, and scaffolding tasks, and recognizing that human control is the necessary engineering mechanism that bridges the output to enterprise quality, reliability, and maintainability. This is a strategy of augmentation, not replacement.
And my conclusion remains that the high operational cost of mandatory human control and verification must be factored into any serious ROI calculation. If the agents are fundamentally unsuitable for core business logic, complex execution, and replacing high-stakes human decision-making, their measurable value is currently confined to activities peripheral to the core business differentiator. Scaling up agent usage without fundamentally changing the human-to-agent supervision ratio means we are implementing an augmented labor strategy, not a capital efficiency one, and operational leaders must budget accordingly.
This discussion really illuminates the critical trade-off facing every operator today: accepting high human supervision to ensure quality and mitigate risk, or mistakenly pursuing autonomy at the expense of necessary engineering principles. The material makes it clear that the most effective, risk-mitigated use of AI agents in 2025 is fundamentally predicated on rigorous human judgment and ownership, which, while reducing the scale of pure automation, maximizes the strategic value of the output.